Good morning, class. Today we will be presenting the topic Big SQL, an offering from IBM. Before we get into Big SQL, it is necessary that we understand what big data is, something that we hear quite often. So, what is big data? While the term big data is relatively new, the act of gathering and storing large amounts of information for eventual analysis is ages old. The concept gained momentum in the early 2000s when industry analyst Doug Laney articulated the now mainstream definition of big data as the three V's. The first V, volume. Organizations collect data from a variety of sources, including business transactions, social media, and information from sensor or machine to machine data. In the past, storing it would have been a problem, but new technologies such as Hadoop have eased the burden. Second V, velocity. Data streams in at an unprecedented speed and must be dealt in a timely manner. RFID tags, sensors, and smart metering are driving the need to deal with torrents of data in near real time. And the third V, variety. Data comes in all types of formats, from structured numeric data in traditional databases to unstructured data such as email, audio, and video. Is it only about the size of the data? Absolutely not. It also refers to advanced analytics such as predictive and behavior analytics. Big data is being generated by everything around us always. Every digital process and social media exchange produces it. Systems, sensors, and mobile devices transmit it. Big data can generate value in many sectors, not just the data oriented ones. According to McKinsey, a retailer using big data to the full could increase its operational margin by more than 60%. If US healthcare were to use big data creatively and effectively to drive efficiency and quality, the sector would create more than $300 billion in value every year. We came across the term Hadoop during the discussion on big data, and most probably you have heard this term being used in conjunction with big data. So, what really is Hadoop? Hadoop is a software ecosystem, a framework that allows for the distributed processing of large data sets across clusters of computers using simple programming models. It is designed to scale up from single servers to thousands of machines, each offering local computation and storage. Probably you can now make the connection of Hadoop being a platform that can be used to churn big data in quick time. So how does Hadoop achieve this processing, that too in a distributed environment? The answer is map source. Map source is the heart of Hadoop. It is this programming paradigm that allows for massive scalability across hundreds or thousands of servers in a Hadoop cluster. Map source is a transformation mechanism that sits on the top of the Hadoop data file system. It splits apart data for parallel processing and recombines the data into a more understandable output. So how does Hadoop fare against conventional relational database management systems? First of all, Hadoop is not a database. The storage mechanisms are fundamentally different. Relational databases store information in tables defined by a schema, whereas Hadoop uses key value pairs as its fundamental unit. Secondly, with a relational databases, users leverage SQL to specify what data they want more than how to obtain it, whereas Hadoop through MapReduce programs specifies what data to retrieve and also how to retrieve it. Thirdly, relational databases typically scale by adding lots of horsepower to a single or small set of database class servers. Hadoop databases scale by adding far more, often hundreds, but low powered machine that works on parallel.
With the foundations laid, let's look at the concept of big SQL. As is the case, some professionals struggle to learn how to work with big data because one of the most popular big data platforms, Apache Hadoop, introduces a wealth of new technologies, including a new query and scripting languages, implicitly creating a steep learning curve. This is where Big SQL steps in. It plays a major role in avoiding the steep learning curve for traditional SQL users wanting to access Hadoop-based systems. So what is Big SQL? Big SQL is the IBM SQL interface to its Hadoop-based platform. InfoSphere Big Insights. Big SQL is designed to provide SQL developers with an easy ramp up for querying data managed by Hadoop. Obviously, the next question would be, what is InfoSphere Big Insights? InfoSphere Big Insights is a software platform designed to help firms discover and analyze business insights hidden in large volumes of a diverse range of data. Basically, IBM's gateway to the world of big data. The next logical question, why do we need big SQL when there is already a dedicated platform with a sophisticated programming paradigm? I'm talking about MapReduce. MapReduce, even though is designed for Hadoop and big data, has a steep learning curve as it brings along with it a basket full of new technology and programming model. Hence, it's difficult to adopt this new paradigm during transitions for lack of time. And also, the availability of experts in this domain is on the lower side. Big SQL fills this void by providing the same capabilities with a familiar and widely known syntax, that is, that of SQL. Now let us understand the architecture of Big SQL in simple terms so that we are well placed to understand how Big SQL works and the utility of it. As you can see, Big SQL supports JDBC and ODBC client access from Linux and Microsoft Windows platforms. In addition, the Big SQL load command can read data directly from several relational databases. JDBC and ODBC are nothing but a way to allow external applications developed in Java, C or C++ to access these databases. Moving on, the SQL engine supports joins, unions, groupings, common table expressions, and other familiar SQL expressions. Depending on the nature of a query, your data volumes, and other factors, Big SQL can use Hadoop's MapReduce framework to process various query tasks in parallel or execute a query locally within Big SQL server or a single node, whichever may be the most appropriate for your query. So the whole larger idea is being able to leverage existing skills and tools already present in a company and perhaps reuse portions of existing applications. As mentioned earlier, Big SQL offers JDBC and ODBC support to Java, C, and C++ application developers. This support system will empower an already resourceful programming community. Finally, let's look at some sample SQL constructs. As you can see, on the left hand side is a create table query. This looks exactly to the ones that we have used in our lab assignments. And on the right hand side, there is a query which has select, from, and where clauses in it. It again is similar to the ones that we have used. So with this, we end our presentation. Thank you.